Go ahead.
All right, so hi, thank you for joining me in my presentation today. I'm really excited to share what I've been working on the entire quarter today. So here's the agenda for today's presentation. We'll have a recap of last quarter, defining what the needs are for the current new prototype, and then going through iterations, and then showing you the final product. So last quarter, Team Travola, me, Akira, and Tony, we created a lab tray for Danny. Thanks to all of our user interviews and great help from Stanford and Dave's guidance, we were able to create a table that, if you remember, it looks like this, using a matte acrylic with a design on the side. And this is what it looks like when it's installed and mounted on this wheelchair. And then the problem that we had with early in the quarter, talking with Stanford, is that there were some problems with the wheelchair that could be addressed and some features added on. So these include making rounded corners, adding an armrest, and creating better clamps. So those were the main three categories that we wanted to address. So more specifically, we wanted to make sure that by creating a better clamp solution that we can easily detach the table from the wheelchair, and then use consistent materials, whereas before we used both Duron and acrylic. We wanted to use acrylic all over. And then finally maintain that smooth motion that we had from the previous iteration. And then so this is a process, so I wanted to show you the clamp process. So the first clamp design that we came up with is a kind of a cube shape that basically has can slide the table on the side here and can screw on. But the problem here, unfortunately, was that it was created for aluminum, that what we planned for in the beginning. So it was fortunately really hard to work with aluminum cutting through the metal, and so we realized that we wanted to go for a different material for this design. So this is what it looks like when that specific design has been included with the lab tray. And then so from the last iteration, you can definitely see the difference between this one having the holes for the hose clamps that we had in the previous quarter, and then going back to the new design, we got completely rid of the holes, and then instead wanted to either screw it on, or in this case of the design, slip on the acrylic. So this is me in the machine shop. Unfortunately, as I explained before, the aluminum was extremely difficult to cut and shape, and so we decided to opt for a more easier solution, which is 3D printing. And so this is the first iteration of creating that design. So we used Ultimaker in the Project 36 lab in the Huang building, and then created this design. However, unfortunately, for this design, another disadvantage that we had, or drawback, is that this one, the infill, basically what it means is the hardness of the material, of the plastic, it was too strong. I think it was an infill of 75% or 100, and that made it really tough to slip on to the pole. And so this one, I have it in my bag here, so basically it doesn't open up. Yeah, if you want to just have a look. So then we opted for the second design, which is this one. And this one is different from the cube design in that it has a more linear shape, and we were able to screw from both the bottom and the top. So with this design, however, we never really got to try this design due to some setbacks that happened within the last few hours. So to recap, what happened is that we couldn't order the right parts, and not on our fault. Amazon gave us 2 light bulbs instead of clamps. Yeah, I had a big fight with them on the phone. But yeah, and then with 3D printing, we did send this to 3D printing, but then somebody had taken out a print, and and I started their own. So it was a little bit frustrating.
Yeah.
But this did not stop us from conducting our user interviews and testing and making some final measurements and adjustments. So this was yesterday. We were able to bring our final cut acrylic piece and test it and to see where it on the acrylic table we should drill holes, and also we made a slight adjustment to the clamp. So the new clamp here that is installed currently has a longer linear edge. So we are able to, instead of having two screws from one at the bottom and one at the top, we have both screws at the top. We thought that in that way we don't have to worry about how the screw goes in the bottom and not being able to see it. So two screws at the top is much more useful and handy, and you can change the location as you wish when it's at the top. So going with showing you some prototypes. This is the first prototype that we had. It uses the same material except it is half the width. Yeah. So this one is the final prototype uses a 1/2 inch, but this is a 1/4 inch of the acrylic. So another thing that we learned during this process is that whereas in the last quarters project we used soldering to insert these pieces in and then put in the screws, but then we realized that this method didn't really work out in the first prototype because it burned through the plastic really fast and left really not helpful marks. So I have an example here to show what happened to the plastic. Basically it burned through and then some of the inserts would come out of the insert of the hole. And so that was kind of unfortunate. So we opted for a different option, which is to basically to screw it in by force. And interestingly enough, it did go through the plastic with a drill. And so in that case, we didn't have to worry about the plastic burning and creating unwanted irregular holes. So this is the prototype that uses the square the square clamp that we had, and then this version uses Duron instead of the acrylic here. We just wanted to test out the thickness of the material and to see whether Duron is an option, but we realized that it's not something that we want to continue using. As this material specifically was used in the first iteration, we wanted to kind of change it up and use consistent materials for this project. And now to the final product. This was picked up this morning. The print took around 12 hours. Yeah, I did not know that it takes really long, but the print basically for 3 clamps it takes 12 hours to print, and once it is off I had to take off the residuals from the plastic.
Yeah. And
then so we printed 3. So you can have a look at this one just in more detail. So that one again has the long edge that could clamp onto the that could screw into the board easier, as it has a larger surface area at the back. So this final prototype consists of all the elements that were discussed in the beginning. So we wanted to, again, use consistent materials with the black acrylic. We increased the thickness by half an inch, and then have the same smooth motion that Danny is familiar with. We didn't want to create a new motion that takes a long time to adapt to and learn. And another aspect is, this material. Tony mentioned yesterday, but he chose a material that is FDA approved, and you can it's like a cutting board, so you can like really eat off this. So no bacteria can grow in this, which is great. And then another aspect is to include the armrest. Using a sponge, you can see here.
Foam.
So inside is like a soft sponge.
Foam. It's called foam.
A foam.
Yeah.
Sorry, a foam. So yeah, we used a foam and then covered it up with a non-slip material. Yeah, if you just want to see. And then yeah, so that is the final product, and we. You know, again, the screws. The great thing about this clamp solution is that we can adjust the placement of it very easily without, you know, making any unwanted holes through soldering. And then, yeah, so this is kind of like the second iteration of this project. And yeah, I'm excited to see where this takes us beyond this project. Yeah.
Okay.
Thank you for listening. Thank you.
Okay, I'm gonna turn this off.
Okay.